Hi, good morning. This is Srinivas Aluwala, working as Assistant Professor in the Department of Computer Science and Engineering, SR Engineering College, Warangal, Telangana, India. Welcome to the presentation on switching. Before we go on knowing what is switching in data communication and networks, let us know the course objectives. The objectives are: understands why switching is needed in data communications, able to know the different types of switched networks in data communications and computer networks. At the end of the course outcomes are the students will be understanding importance of switching in data communications, knows the mechanism of implementing the switching. Now coming to the switching. Why switching is needed in data communications and computer networks? As we know, a network is a set of connected devices. Whenever we have multiple devices, we have the problem of how to connect them to make one-to-one communication possible. One solution is to make a point-to-point connection between each pair of devices or between a central device and every other device. These methods, however, are impractical and wasteful when applied to very large networks. The number and the length of the links require too much infrastructure to be cost efficient, and the majority of those links would be idle most of the time. The other topologies employing in the data communication networking is multi-point connections, such as a bus, are rolled out because the distances between devices and the total number of devices increase beyond the capacities of the media and the equipment. And to this problem, a better solution is a switching. A switched network consists of a series of interlinked nodes called as switches. Switches are the devices capable of creating temporary connections between two or more devices linked to the switch. Looking at this slide presented over here as a switched network, the end systems are labeled as A, B, C, D, E, F, G, H, I, J, and so on. And the switches are labeled as 1, 2, 3, 4, and 5. Each switch is connected to multiple links. Traditionally, three methods of switching have been important: circuit switching, packet switching, and message switching. The first two are commonly used today. The third has been phased out in general communications but still has networking applications. Packet switch networks can be further be divided into two subcategories: virtual circuit networks and datagram networks. Firstly, we go for seeing what is a circuit switch network. A circuit switch network consists of a set of switches connected by physical links. A connection between two stations is a dedicated path made of one or more links. However, each connection uses one dedicated channel on each link. Each link is normally divided into n channels by using the different mechanisms such as the frequency division multiplexing or time division multiplexing. A circuit switch network is made up of set of switches connected by physical links in which each link is divided into n channels. Let us look at the tribal circuit switch network. Here A is the sender and M is the receiver destination, where each switch, there are 4 switches in the diagram, and each switch is connected to n number of channels, and every switch has a multiplexer connected through a single link to another switch. So in a circuit switch network, before A wants to send a message to M or a data packet to M, a dedicated link or a temporary dedicated link need to be established to pass the data from the sender to the receiver. In a circuit switching, the resources need to be reserved during the setup phase. The resources remain dedicated for the entire duration of the data transfer until the termination or the teardown phase. Switching at the physical layer in the traditional telephone network uses the circuit switching approach. Communication in a circuit switch network requires 3 phases. They are connection setup, data transfer, and connection teardown. Setup phase. Before the two ends can communicate, a dedicated circuit or a temporary dedicated path needs to be established. The end systems are normally connected through dedicated lines to the switches. So Connection setup means creating dedicated channels between the switches. As soon as a dedicated channel is being established from a sender to the receiver, the data transfer takes place. What we call it as a data transfer phase. After the establishment of the data dedicated circuit or a dedicated path, the two parties, that is the two end systems, can go for transferring the data among themselves. At the end, the tear down phase, when one of the system needs to disconnect, a signal is sent to each switch to release the resources. When the tear down phase or one of the party has a request to release the resources, they takes the termination of the connection, that is the dedication link or the channel path is going to be terminated. There ends the data transfer among both the devices. As a part of the circuit switched networks, the efficiency of the circuit switched network is not as efficient as the other two types of the networks, because resources are allocated during the entire duration of the connection. Delay. Although a circuit switched network normally has low efficiency, the delay in this network is minimal, because the data transfer, during the data transfer, the data are not delayed at any switch, because the dedicated path is allocated during the setup phase. There is no waiting time at each switch. The total delay is due to the time needed to create connection, data transfer, and only the disconnect the circuit. Here, looking at the picture, we can go for understanding the delay in a circuit switch network, as the delay is a part of making the connection, data transfer, and making the disconnection among the two end systems. That is how we go for calculating the total delay in a circuit switch network. Delay caused by the setup equal to propagation time of the source computer request to the request to signal transfer rate plus propagation time of the acknowledgement from the destination computer plus signal transfer time of the acknowledgement. The delay due to data transfer is the sum of two parts. One is propagation time, the other one is data transfer time. The third one needed is to tear down the circuit, that is in case in which the receiver requests disconnection, which creates the maximum delay. Thank you.